All right, so how to conduct follow-on missions after you just got done registering your mortars. All right, plotting board here with everything already set up just to speed up the process of this class, but just so you understand how it's going to look on my board with my data sheet. Everything from my registration class is still the same. All right, nothing has changed here. I still have my grid intersection of 0, 1 and 5, 9. My registration point at the altitude of 1070, mortar position at the altitude of 520, and then my refer deflection scale is down here, which you can't see off the screen right now, at a mounting azimuth of 3650. All right, so initial setup, everything remains the same from our registration. Still using our surveyed firing chart, so we know that these grids are known to surveyed accuracy. All right. Now, continuing to talk about our registration transfer limits, right? I kind of beat it up a little bit for our registration class. I misspoke a little bit. I don't know if you guys caught it, but I said you had 300 meters, which in fact should be 3,000. I know you guys are all stellar at math, so you probably have caught that, but it's 3,000 meters in total for your range, for your transfer limits, and then you have 800 mils for that entire thing. All right, so if you're trying to cover an entire circle, right? 6,400 mils in a circle. You're trying to cover every portion of that circle. You're going to need 8 of these transfer limits, all right? So 8 separate registration points. Just keep that in mind if you're trying to do with some planning purposes. All right, so we did registration. Now, any mission, like I said prior to, any mission that falls in these transfer limits, we need to apply all those corrections and an additional correction, which I'll cover here in a second, to these missions. All right, and you'll see how that looks right here. All right, so I have my computer's record, and I'm standing by for my FO. He comes back with a just fire, and we're shifting from our RP1. He gives his OT direction of 3,500 with a right 200, drop 100, and then up 250 with a target description of an RPGT. All right, so shifting from RP1, go ahead and knock out our FDC order. So mortar fire for effect section, number 2 gun, 1 round. Now, because we just got done firing registration, we're still in our registration transfer limits, our basis for correction is RP1. All this means is now we're going to apply all those registration corrections that we got to our initial chart data to get our command data with those applied. And you'll see how that looks. Our shell and fuse, HE quick and adjust, proximate fire for effect. We have 3 rounds when ready. All right, so how this will look on the board, I'm going to index that OT direction, 3,500. And simply apply those corrections that he gave with the right 200, drop 100. Now remember these up and downs, vertical shift based off of altitude. All right, so that would be based off of our RP altitude of 1070. So I've applied these corrections already. Once I have those made, now I can go ahead, parallel plot with my mortar position. And obtain my chart deflection. So I get a chart deflection of 2719. Now I'm going to pull over my basis for correction, so all of my registration corrections. So my deflection correction that I got from registration of the left 11, my chart range that I get off of my plotting board of 3075. Now I got an up 250, so I'm going to go up from the RP altitude of 1070 and then compare that to my mortar altitude of 520 to get a vertical interval of positive 800. All right, so my new target is 800 meters higher than my mortar position. All right, so I divide that by 2 to get my altitude correction of positive 400. Now we got a range correction from registration, but that was specifically for that mission. So now for this mission, we need to go ahead and figure out what our range correction is. We're simply going to do that with our little formula here. All right, so we need our initial chart range. We're going to round that to the nearest 100, express it in thousands, and then we'll multiply it by the range correction factor from our registration mission. You can see here I have that annotated below. So from registration, I had an RCF of positive 3.9. And remember, like I said, for every 1,000 meters within those transfer limits, we have to apply an additional 39 meters here. So that's what we're doing when we express these in thousands. Now we're applying that additional 39 to get our new range correction factor. Or sorry, range correction. So that initial chart range that we just got with this of 3075, round that to the nearest 100, gives us 3100, express that in thousands, is 3.1. All right, now we can multiply that by that positive 39, which gives us a decimal of 120.9. Go ahead, round that to the nearest whole number. And our RCF was a positive, so now our new range correction for this mission will be a positive number. All right, once we have that, we need to figure out our total range correction. All right, so if you look here on top of my plotting board, I have my FDC tools from Goons Up and Mission Essential Gear. Page 15 breaks it down very well on how to apply these for the follow-on missions. All right, so page 15 for follow-on missions if you want to refer to your tools if you have them. All right, so total range correction. I just got my range correction of positive 121, all right, from the previous slide. Now I need to get my altitude correction. So I already determined that to be a positive 400. Now I'm going to apply my altitude correction to my range correction, in this case to get a positive 521. Now once I have that positive 521, I can then bring it back into my computer's record. So I have my range correction written here of positive 121. I applied my altitude correction to give me a TRC, or total range correction, of positive 521. Now once we have that total range correction, we need to apply that to every follow-on chart range from here on out. All right, so if I apply positive 521 to my chart range of 3075, I get a command range of 3600. Now once I have that, I can go into my firing tables, get my charge, lowest charge. Remember, I had charge 7 because I'm using 300 series. I have my azimuth from my plotting board of 3731. I obtained my max ord of 1389 and time of flight of 33.7 from my firing table. And then I have an angle T of 230. Angle T is not in effect, so I don't need to pass that to the FBO. All right, now moving into my initial fire command. So mortar to follow is section, because mortar to fire for effect is section. Shell and fuse, HE quick, mortar to fire will be 2-gun. All right, method of fire, 1 round in adjust, 3 rounds prox in the fire for effect. Now for our deflection. We're going to take our initial chart deflection, in this case, of 2719, and apply that deflection correction from registration of left 11. Now large left is add, so I'm adding 11 to this deflection to get a command deflection of 2730. I pull over charge 7. Now I'm going to get my corresponding elevation of my command range of 3600 of 0948. Once I pass those orders to the gun, they can go ahead and fire that 1 HE round. All right, once they do that, I'm solid on the plotting board, so I'm going to index my OT direction to 3500. as I'm standing by, I can go ahead and pull down my deflection corrections. So remember, I'm pulling this and applying it to every chart deflection from here on out, as well as my total range correction of positive 521, because I'm applying it to every chart range from here on out. All right, so our FO comes back with an add 50, fire for effect. Now I can apply that add 50, then parallel plot. And obtain my new chart data. So I'm getting a chart deflection of 2722 and a chart range of 3125. Now we're in fire for effect. So our mortar to fire will change to section. Our method of fire will be 3 rounds prox. Now we need to apply this left 11 to our chart deflection. So add 11 to this to get a command deflection of 2733. Applying our total range correction to our chart range to get our command range of 3650. Now we're pulling in our firing table our corresponding elevation to that command range, which is 0924. Alright, so it's 3 rounds prox, and then fire for effect. 4 guns, we get 12 rounds prox, and then we have that 1 HE up above. So they hang and fire those 12 rounds. Our observer comes back with end of mission with a BDA of 40% casualties. Now actions on the plotting board, I can go ahead and erase everything but my last plot and save that as my target number of Charlie Hotel 0050. Alright, then I can move into my data sheet, update this with my target number, our chart deflection of 2722. Remember, this is my final chart deflection, my final chart range of 3125. Pulling down our deflection correction from registration of left 11. Then we had a range correction for this mission of positive 121. Our new altitude of 1320 for that target. Remember, we had to apply that up correction to our altitude of 1070. All right, which gave us a vertical interval 800 and a positive 400 altitude correction. Moving into our firing data, we had a command deflection after we applied that left 11 of 2733, and a command range of 3650 after we applied our total range correction of positive 521. Charge 7, corresponding elevation with that being 0924. All right, our target description was RPG team. Our method of engagement was 3 rounds prox with our section. Estimated 40% casualties, and we expended a total of 1 HE and 12 prox. All right, so that covers how to apply everything after you conducted a registration mission. So every follow-on mission, you're going to obtain a new range correction, apply that to your altitude correction to get a total range correction based off of the range correction factor you got from registration mission. All right, like always, if I have any questions, feel free to hit me up on YouTube or Instagram and let me know.